Assalamualaikum, my name is Muhammad Fakullah. Our team is led by Fauzan, and then the other members is Izzuddin, Muhammad Noor, myself, Fakul, and Hazim. So the project name is Eco Heaven, cadangan membina kediaman bagi pekerja dan pelawat hospital KPJ Batu Pahat, Johor Darul Takzim, where the location is 5 Jalan Mutiara Gading Utama, Batu Pahat, Johor. The total build-up area approximately 3,900 meter square over 3 story. So on the slide, there are key plan and project site visualization.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin, and today I will continue the presentation on how we do menu calculation for beam design. First of all, we do the determine loadings and then calculate into the ultimate design load, which is 1.35 GK plus 1.5 QK. And then we find design moment and shear. So for continuous beam, we do load combination before start moment distribution and choose the higher moment value for each support. To continue that, we calculate the design reinforcement using the formula to find the required steel area after determine the Z value that should be under 0.95D. We continue to the check deflation and shear to ensure the span over depth ratio is allowable. After that, we verify the shear strength must be over the shear design. And then we serviceability checks for continuous beam to ensure the deflection is under limit, and then we check the cracking for bar spacing. And lastly, we do detailing for both continuous beam and simply supported beam.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rafan and I'll be presenting about slab design. So first, we have to determine the slab thickness. We use the STEM software to determine the thickness of slab. Next, we should determine the loadings and calculate it into the design load. Moving on to calculate design moment for both spans alongside their mid-span. And then we go on to calculate design reinforcements. We should find the AS required for the design, then make sure the AS provided is higher than AS required. Then we should check shear and deflection, making sure that shear strength is higher than shear design and span per ratio is lower than span per ratio allowable. And we move on to serviceability check SLS. We should ensure max spacing is lower than max allowable bar spacing. And finally, detailing. We should use the AS provided for post reinforcement bars and secondary bar, labeling them for clarity in the drawing.
Assalamualaikum, my name is Fakul. I will talk about the column design. The column design start with determine load acting on column, where we'll find the dead load and live load. After that, we will do the apply load combination, which is the ultimate design load 1.35 GK plus 1.5 QK. After that, we will choose the preliminary column size based on architectural layout and estimated load. Must consider slenderness and space constraint. Next is calculate axial load and moment, if any, by using software estimate or manual analysis. We need to consider an axial or biaxial bending if applicable. After that, design longitudinal reinforcement. Under this design, we need to ensure min and max steel ratio satisfy, ensure bar spacing allows compaction and cover, ensure reinforcement are bigger than required, as the capacity check is design load lesser than partial safety factor time with capacity. Next is design lateral touch shear reinforcement, where the checking under this step is tie spacing complies with code, anchorage and hook provided, ties placed at every bend and lap. The next checking is column slenderness, where under this column slenderness checking, we need to consider column are short or slender and the slenderness is lesser than allowable. Magnify moment considered in design. After that, we need to check the SLS serviceability, where there is crack control, bar spacing and cover, and then deflection, usually not critical in short column. Durability class and cover for exposure like XC3. The checking we need to do under this SLS check is bar spacing for crack control, cover thickness must bigger than 25 mm, ensure fire resistant requirement like 1 hour. The last but not least, we need to do the detailing, where we will finalize drawing, column size, bar size, number, spacing, tie size and spacing, and we will label on drawing for site use. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim bin Rahman and I will talk about the foundation design. So for our group, we have chosen the pile foundation due to its soil condition and our structure. So first is we have to determine the loadings such as the dead load, live load and structure load, and we have to convert them into the ultimate design load. Next is we have to determine the type and the size of the pile cap. We have to calculate the number of pile cap and we have to determine the spacing between the piles. And next step is we have to design the main reinforcement for the longitudinal and the transverse bar. So for design of main reinforcement, we have to calculate the area of reinforcement, which is the AS, and we have to consider the minimum and the maximum reinforcement area. And after that, for the next step, we have to design for the shear. So there is three. First is for the vertical shear, we have to design the shear resistance while ensuring that the VRDC is larger than the VED, which is the shear force. And then we have to determine the punching shear. So we have to ensure that the pi spacing, which is pi spacing is lesser than the 3 pi. And then we have to determine the max punching shear. So that is the example for that is maximum shear resistance. And then we have to do the serviceability check or SLS for the check for the cracking. First, we have to design for the crack width that is 0.3 millimeter, and then we have to determine the allowable bar spacing for the crack control. In this step, we have to ensure that the maximum bar spacing is lesser than the maximum allowable bar spacing. And the last step is detailing. So in the detailing, we have to finalize the drawing. For example, the pile cap layout. We have to determine the bar size, number and spacing, and to be put into the layout. And we also have to determine the concrete cover size and also the spacing. And all of them, we should label it on the drawing for the site use. So that's all for me.
Assalamualaikum, I am Fauzan and I will be presenting for our project's design schedule. So here is the design schedule for the entire IDP structural work along 8 weeks. So we started the project on 19 March with an introductory briefing by our lecturer in Senior Technology Shangguang. After that, we received the architectural drawings and began the process of converting them into structural drawings. Throughout the duration of the project, we attended weekly lectures focused on key structural design topics, including beam design, column design, slab design, and also the foundation design. So we have 2 reports to be submitted, which are preliminary structure report that submitted on 31st April, and lastly, the full report structure that submitted on 30 April. To design in STM software, we have first to convert the architectural drawing into structural drawings. So here's the process to design in STM software. So we can start by opening the new file and fill the work description and floor parameter. Next, we need to edit the project parameters such as the practice code, the value of FYK, FCK, minimum and maximum diameter bar, and many more. Then we can start to draw the grid line following the architectural drawing layout, and we can assign the beam. So first we use the architectural drawing where we propose the size of 300 times 500 for the beam. Next, we can start assign the column where we use the architectural drawing layout using the 300 times 300 column size. After that, we assign the floor with the thickness of 150 millimeter with the value GK vary in the range of 1 to 1.5 kilonewton per meter square, and the value of QK, we are referring the Code of Malaysian Standard in Eurocode 1 National Annex. After that, we assign the brick wall and we copy the floor parameter to the upper floor and edit following the structural drawing. And lastly, we run the analysis and make some adjustment until the batch process is completed. After the batch process is completed, we can view the design result for all elements that are available, such as slab result, beam result, column result, and also the foundation result, where the result will be showing the arrangement of bar and also the type of foundation, the size of column, and many more. The STM output also prepare the summary result and quantity takeoff value that might be useful for our use. For summary result, it is useful for us to compare the manual calculation with the STM output, where we can obtain the value of the maximum agile load, the maximum bending value, and the number of bar used in the elements. And lastly, the quantity takeoff value is useful for us to prepare the bill of quantity. From the STM output also have shown the costing value, but for this project we use di jadual kadar harga, so we might do some adjustment from the quantity take of value.
Okay, next we will move on to comparison of software and manual calculation. So for software, calculation is very fast. It can analyze complex models in seconds. And for manual calculation, it is time consuming, especially for large modular designs. Moving on to accuracy, software calculation has a very, very high accuracy if inputs and settings are correct, while manual calculation is prone to errors, especially in iterative process. Then we go to learning curve. Software calculation requires familiarity with software UI and commands. For manual calculation, requires strong fundamentals and deep understanding of structural theory. Then for visualization, software calculation offers graphical output and 3D modeling, while manual calculation offers manual sketch or diagrams required. It is generally more abstract. For code compliance, software calculation is often integrated with design codes like Eurocode, BS, UBC, MSEN, and etc. But for manual calculation, it must be checked manually against relevant courses. Finally, for documentation, software calculation is have auto-generated reports, drawings, and calculation sheets, while manual calculation needs manual preparation of all outputs and reports.
What do we gain from this IDP course is first practical application of the theoretical knowledge. So we are able to apply the classroom concepts such as a Eurocode design standard to the design application, and then exposure to the real engineering workflow. In this course, we understand the workflow of a civil and structural consultant firm, from interpreting architecture drawing to develop a detailed structural drawings. After that, teamwork, project and management. So we managed to improve our communication skill based on the IDP course. After that, competency in software tool. Develop proficiency in Steam and AutoCAD during the design process. After that, design standard and documentation skills. We learn how to comply with the building codes submission process via the one-stop center system. And then critical thinking and engineering judgment. So in this course, we improve our decision making by evaluating the difference manual calculation and the software calculation. And lastly, preparedness for future career. So this course are able to teach us how to be professionalism in prepare the documentation.